Derating of conductors is a critical aspect of electrical installations. Let's consider a scenario with a three-phase feeder consisting of four 4/0 aluminum conductors plus a ground, and three single-phase feeders consisting of three 2/0 aluminum conductors plus a ground. The question is whether the three-phase feeder can be fused at 125 amps and the single-phase feeders at 100 amps, considering they will be installed in a 3.5-inch polyvinyl chloride, or PVC, pipe and a trough over 24 inches long, with all conductors having the same insulation. The answer is yes, the three-phase feeder can be fused at 125 amps. However, the single-phase feeders cannot be fused at 100 amps. It is essential to consider the derating factors for conductors in conduits and troughs. For a conduit, the conductors must be derated by 80%, and for a trough over 24 inches, the conductors must be derated by 70%. To calculate the ampacity, let's start with the three-phase feeder. The conductor ampacity for a 4/0 aluminum conductor is 160 amps. With a derating factor of 80% for the conduit, the derated ampacity is 128 amps. For the single-phase feeders, the conductor ampacity for a 2/0 aluminum conductor is 110 amps. With a derating factor of 70% for the trough, the derated ampacity is 77 amps. Since the derated ampacity of the single-phase feeders, which is 77 amps, is less than the desired fuse rating of 100 amps, they cannot be fused at 100 amps. The fuse rating must be derated to match the derated ampacity of the conductors, so the single-phase fuse rating should be 77 amps. Now let's talk about the temperature rating chart. The 90°C column in the temperature rating chart is used for derating conductors undergoing continuous operation at ambient temperatures not exceeding 30°C or 86°F. The temperature rating chart also has other uses. The 75°C column is used for intermittent lows or emergency conditions, and the 60°C column is used for cold environments. Here are some examples of temperature rating chart usage. A conductor rated for 100 amps in the 75°C column can carry 115 amps at an ambient temperature of 60°C or 140°F. A conductor rated for 150 amps in the 90°C column can carry 190 amps at an ambient temperature of 40°C or 104°F. These examples demonstrate how the temperature rating chart is used to adjust the ampacity of conductors based on ambient temperature. It is crucial to understand and apply these derating factors and temperature ratings to ensure the safe and efficient operation of electrical systems. Now let's dive deeper into the specifics of conductor derating and temperature correction, as well as some practical considerations. The National Electrical Code, or NEC, provides detailed guidelines for conductor ampacity derating and temperature correction. It is important to consult the latest edition of the NEC for the most up-to-date information. When calculating conductor ampacity, you must consider the following factors. Firstly, the conductor type and size. Secondly, the insulation temperature rating. Thirdly, the ambient temperature. Fourthly, the number of current carrying conductors in a raceway or cable. And fifthly, any other applicable derating factors. The NEC provides ampacity tables for different conductor types and sizes at specific insulation temperature ratings. These tables assume an ambient temperature of 30°C or 86°F. If the ambient temperature exceeds 30°C or 86°F, you must apply a temperature correction factor to reduce the conductor ampacity. The temperature correction factors are provided in the NEC tables 310.15, B1 and 310.16. In addition to temperature correction, you must also consider the number of current carrying conductors in a raceway or cable. When multiple conductors are installed together, they generate heat, which can reduce the conductor ampacity. The NEC requires you to apply a derating factor based on the number of current carrying conductors. The derating factors are provided in NEC table 310.15. B3, 8 for example, If you have 4 to 6 current carrying conductors in a raceway or cable, you must derate the conductor ampacity to 80% of its original value. If you have 7 to 9 current carrying conductors, you must derate the conductor ampacity to 70% of its original value. The derating factors for the number of current carrying conductors are cumulative with the temperature correction factors. Therefore, you must apply both factors to determine the final derating ampacity of the conductor. In the example provided, the three-phase feeder consists of 4/4/0 aluminum conductors plus a ground. The ground conductor does not carry current under normal operating conditions, so it is not considered a current carrying conductor for derating purposes. Therefore, the three-phase feeder has 3 current carrying conductors, 1 for each phase. Since there are only 3 current carrying conductors, no derating is required for the number of conductors. However, the single-phase feeders consist of 3 2/0 aluminum conductors plus a ground. In this case, there are 2 current carrying conductors, 1 for the phase conductor and 1 for the neutral conductor. The ground conductor is not considered a current carrying conductor. Since there are only 2 current carrying conductors, no derating is required for the number of conductors. When installing conductors in a conduit or trough, you must also consider the conduit fill requirements of the NEC. The NEC limits the percentage of the conduit that can be filled with conductors. The conduit fill requirements are provided in NEC Chapter 9, Table 1. The conduit fill requirements vary depending on the type of conduit and the number of conductors. For example, for a rigid metal conduit, the maximum conduit fill is 40% for 3 or more conductors. For a flexible metal conduit, the maximum conduit fill is 31% for 3 or more conductors. If the conduit fill exceeds the maximum allowed, you must increase the size of the conduit to accommodate the conductors. In the example provided, the conductors will be installed in a 3.5-inch PVC pipe and a trough over 24 inches long. The NEC does not specify conduit fill requirements for troughs. However, it is important to ensure that the conductors are not overcrowded in the trough, as this can lead to overheating. When selecting conductors for an electrical installation, it is important to choose conductors with the appropriate insulation temperature rating. The insulation temperature rating is the maximum temperature that the conductor insulation can withstand without degrading. The NEC requires you to select conductors with an insulation temperature rating that is suitable for the operating conditions. The insulation temperature rating is marked on the conductor insulation. Common insulation temperature ratings include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. As mentioned earlier, the 90 degrees Celsius column in the temperature rating chart is used for derating conductors undergoing continuous operation at ambient temperatures not exceeding 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, you must use the 75 degrees Celsius column or the 60 degrees Celsius column, depending on the ambient temperature. The 75 degrees Celsius column is used for intermittent loads or emergency conditions. The 60 degrees Celsius column is used for cold environments. It is important to note that the ampacity of a conductor is also affected by the type of termination used. Terminations are the devices used to connect conductors to equipment such as circuit breakers, switches, and receptacles. The NEC requires you to use terminations that are rated for the conductor size and insulation temperature rating. Some terminations are only rated for use with 60 degrees Celsius conductors or 75 degrees Celsius conductors. If you use a termination that is not rated for the conductor insulation temperature rating, you must derate the conductor ampacity accordingly. In summary, derating of conductors and temperature correction are essential aspects of electrical installations. It is important to consider all applicable factors, including the conductor type and size, the insulation temperature rating, the ambient temperature, the number of current carrying conductors, and the conduit fill requirements. By following the guidelines of the NEC, you can ensure the safe and efficient operation of electrical systems. Now, let's discuss some additional factors that can affect conductor ampacity and derating. Firstly, altitude can affect conductor ampacity. At higher altitudes, the air is less dense, which reduces the ability of the air to cool the conductors. The NEC does not provide specific derating factors for altitude, but it is generally recommended to derate conductors by 1% for every 1,000 feet above sea level. Secondly, direct sunlight can also affect conductor ampacity. When conductors are exposed to direct sunlight, they absorb heat, which increases their temperature. The NEC does not provide specific derating factors for direct sunlight, but it is generally recommended to shield conductors from direct sunlight whenever possible. Thirdly, conductor bundling can also affect conductor ampacity. When conductors are bundled together, they generate heat, which can reduce the conductor ampacity. The NEC provides derating factors for conductor bundling in Table 310.15. 3. The derating factors vary depending on the number of conductors in the bundle. Fourthly, the type of raceway can also affect conductor ampacity. Some raceways, such as metal conduits, provide better heat dissipation than other raceways, such as PVC conduits. The NEC does not provide specific derating factors for different types of raceways, but it is generally recommended to use metal conduits in high ambient temperature environments. Fifthly, the presence of harmonics can also affect conductor ampacity. Harmonics are distortions of the sinusoidal waveform of alternating current, or alternating current electricity. Harmonics can cause conductors to overheat, which can reduce their ampacity. The NEC requires you to consider the effects of harmonics when selecting conductors for systems with nonlinear loads, such as electronic equipment. Sixthly, continuous loads can also affect conductor ampacity. A continuous load is a load that operates for 3 hours or more. The NEC requires you to increase the size of conductors for continuous loads by 25%. This is because continuous loads generate more heat than non-continuous loads. Seventhly, voltage drop can also affect conductor selection. Voltage drop is the decrease in voltage along a conductor due to the conductor's resistance. The NEC recommends that voltage drop should not exceed 3% for feeders and 5% for branch circuits. If the voltage drop exceeds these limits, you must increase the size of the conductors to reduce the voltage drop. Eighthly, the conductor material can also affect conductor ampacity. Copper conductors have a higher ampacity than aluminum conductors for the same size. This is because copper has a lower resistance than aluminum. The NEC provides ampacity tables for both copper and aluminum conductors. Ninthly, the type of insulation can also affect conductor ampacity. Different types of insulation have different temperature ratings. The NEC requires you to select conductors with an insulation temperature rating that is suitable for the operating conditions. Lastly, the location of the conductors can also affect conductor ampacity. Conductors installed in enclosed spaces, such as attics or crawl spaces, will have a lower ampacity than conductors installed in open spaces. This is because enclosed spaces trap heat, which reduces the conductor's ability to dissipate heat. In addition to the factors listed above, there are other factors that can affect conductor ampacity and derating. It is important to consider all applicable factors when selecting conductors for an electrical installation. It is also important to consult the latest edition of the NEC for the most up-to-date information. By following the guidelines of the NEC, you can ensure the safe and efficient operation of electrical systems. Let's address some common misconceptions about conductor derating and temperature correction. Firstly, some people believe that the 90°C column in the temperature rating chart can be used for all applications. This is not true. The 90°C column can only be used for conductors undergoing continuous operation at ambient temperatures not exceeding 30°C or 86 degrees Fahrenheit. Secondly, some people believe that derating conductors is only necessary for large installations. This is also not true. Derating conductors is necessary for all installations where the ambient temperature exceeds 30°C or 86 degrees Fahrenheit, or where there are multiple current-carrying conductors in a raceway or cable. Thirdly, some people believe that the NEC is just a set of recommendations, not a set of requirements. This is not true. The NEC is a set of legally enforceable requirements in many jurisdictions. It is important to comply with the NEC to ensure the safety of electrical installations. Fourthly, some people believe that they can ignore the NEC if they are not licensed electricians. This is not true. The NEC applies to all electrical installations, regardless of whether they are performed by licensed electricians or not. Fifthly, some people believe that they can use smaller conductors than required by the NEC if they are using energy-efficient equipment. This is not true. The NEC requires you to use conductors that are sized to carry the load, regardless of the energy efficiency of the equipment. Finally, some people believe that they can save money by using smaller conductors than required by the NEC. This is not true. Using smaller conductors than required by the NEC can create a safety hazard and can lead to equipment damage. It is always best to err on the side of safety and use conductors that are sized according to the NEC. Understanding the intricacies of conductor derating and temperature correction ensures safety and efficiency in electrical installations. Always consult the latest NEC guidelines and seek professional advice when necessary.